A comet, a celestial voyager composed of ice and dust, hurtles through the vast expanse of space. As a comet nears the sun, its icy nucleus heats up, releasing gas and dust that form a glowing coma and often a spectacular tail. The journey of a comet can be perilous, fraught with encounters that can lead to spectacular collisions. Over eons, even seemingly improbable events, such as a comet striking another celestial body, become almost inevitable. These cosmic collisions, while potentially destructive, are fundamental to the universe's ongoing story of creation and change. By studying these impact craters, scientists can piece together the timeline of our solar system's evolution. Imagine a comet, a cosmic iceberg, set on a collision course with an asteroid, a rocky relic from the early solar system. The impact sends shockwaves rippling through space, shattering the celestial bodies and scattering debris far and wide. The energy released in these collisions is staggering, dwarfing even the most powerful explosions on Earth. The impact craters left behind serve as lasting reminders of these cosmic encounters, providing scientists with valuable clues about the composition and history of these celestial objects. By studying the size, shape, and distribution of the debris field, scientists can reconstruct the events leading up to the impact. Fragments, now liberated from their parent bodies, embark on new trajectories, some potentially finding their way to Earth as meteorites. Our moon, a silent sentinel in the night sky, bears the scars of countless cosmic encounters. Unlike Earth, with its protective atmosphere and active geology, the moon preserves the history of these impacts with remarkable clarity. Each crater, a frozen moment in time, tells a story of a collision with a comet or asteroid. The size and morphology of these craters can reveal crucial information about the impactor, such as its size, speed, and angle of impact. By studying the distribution and characteristics of craters on these bodies, scientists can glean insights into the frequency and intensity of impacts in different regions of the solar system over time. Section 4. The Earth-Shattering Potential of Cosmic Collisions. Unlike our airless neighbors, Earth possesses a protective shield, its atmosphere. This gaseous envelope acts as a planetary armor, shielding us from the constant bombardment of small meteoroids. However, larger objects, such as comets, pose a more significant threat. When a comet enters Earth's atmosphere, it experiences intense friction, causing it to heat up and potentially break apart. Larger ones can survive atmospheric entry, their fragments potentially reaching the surface and causing significant damage. The most famous example of a cometary impact on Earth is the Chicxulub event, which led to the extinction of the dinosaurs. The impact triggered global wildfires, tsunamis, and a prolonged period of darkness and cooling, drastically altering Earth's climate. Section 5. Cosmic Impacts and the Fate of Our Planet. The threat of cosmic impacts is a stark reminder of our planet's vulnerability in the vastness of space. Scientists and engineers are actively developing methods to detect, track, and potentially deflect hazardous asteroids and comets. Some scientists believe that comets, carrying water and organic molecules, may have delivered the essential ingredients for life to our planet billions of years ago. By unraveling the mysteries of these celestial encounters, we gain a deeper appreciation for the delicate balance that sustains life on Earth. Section 6. Unlocking Cosmic Secrets, the Value of Impact Craters. Impact craters, the lasting scars of cosmic collisions, serve as invaluable windows into the past. By studying the size, shape, and distribution of impact craters, scientists can piece together a timeline of past impacts. The impact craters on Earth, often eroded or buried over time, can still provide valuable insights into past events. Geologists use a variety of techniques, such as geophysical surveys and drilling, to study these features. The study of impact craters has led to a deeper understanding of Earth's geological history, including the formation of continents and the rise of life.